Now we want to compute the expectation of y. We know y is random variables. So for part A, y equals a, and we know here a is also random variable, y is also random variable, but this not random variable. So first we want to write it down, the basic notation expectation of y, which is a cosine omega t plus theta. Since only a is random variable, so this is just like a constant or parameters, so we can take the cosine out and the expectation of a. Since a is Gaussian random variable, with mean mu and variance sigma square. So here is obviously cosine times mu. And the variance of y is variance of a times cosine omega t plus theta. We know the variance, I have a constant here. If I take that out, it's cosine square times variance a, which is sigma square. Sigma square times cosine square. So we know the expectation of y square from the from the expectation and also variance. You can find the expectation of y square. So I give you the answer is mu square plus sigma square times cosine omega t plus theta. Next, B. I know y is random variable, and here is theta is random variable. Theta is here. So that means a and omega and t are not random variable. So again, want to find the expectation of y. Is the expectation of a cosine omega t plus theta. Only this random variable. So since this is only the random variable, I can take a outside the expectation, and it's cosine omega t plus theta. Here is a function of a random variable. So an expectation of a function of a random variable is uniform from 0 to 2 pi. So from 0 to 2 pi, cosine omega t plus theta, all the possible outcomes of a function times the weightings, uniform, so it's 1 over 2 pi d theta. And we integrate a cycle, and the cosine is odd function. So this integration is 0. Now we want to find the expectation of y squared. For part A, because it's easier, a is outside and times a constant, times the parameters. So we find the variance first. But now since it's combined with cosine, so we just directly find the y squared, which means a squared times cosine squared omega t plus theta. Here the theta is random variable. So it's a squared outside, and expectation of this is the integral from 0 to 2 pi cosine squared omega t plus theta times the weightings d theta. Here we know the formula cosine 2 theta equals 2 times cosine square minus 1. So I take the 2 pi outside, is 0 from 2 pi. Here is cosine 2 omega t plus theta divided by 2 plus 1/2 d theta. Again, this part goes to 0. I only have 1/2 to integrate from 0 to 2 pi. Finally, I got a squared divided by 2. Part C. Now, t is the random variable. So, a omega theta are not random variable. It's just the parameters. You don't need to care really much about this a, w, and theta. So for the expectation of y is the expectation of a cosine omega t, this is t, plus theta. We take a outside and then take the integration. A times, since it's a uniform, continuous, so it's integration from minus pi over omega to pi over omega times cosine omega t plus theta dt. Cosine in this period 0. And for the expectation of y squared, it's the same thing, so I take the a squared outside. A squared outside. And the integration is still like from minus pi over omega to pi over omega. And here's the cosine squared omega t plus theta. Actually, I still need to time the weightings. The weightings will be 2 pi over omega dt. But since this is still like a number, so you can still take it out and then integrate the cosine. Still 0. Here is a cosine square, and use the formula for part B. Then finally, your exercise is a squared over 2.